By the way, everybody, we are recording this event and we will make it available afterwards in one form or another. All right. So with that said, we are moving on to the next point on the agenda, which is going to be a little demonstration by Mike. Hey, Mike, thank you so much for joining us.
Thank you very much for having me, Andy. It's wonderful to be here. I'm a recent PhD graduate from Georgia Tech. I got my degree in music technology, which I think is really at the intersections of engineering, technology, science, and art, and specifically art through music as dynamic forms change through time. And so I am an outsider to IU. I came here in the summer and joined Greg Lewis in the socio-neurophysiology lab, and became aware of Amatria through work there, and was introduced to Andy and Kati, who have graciously allowed me to interact with the sculpture, and I've brought a lot of people in into the Living Architecture Systems group who helped me with this process. I'm going to share my screen, and I have a few slides here to share what I've been up to. Okay, great. So my background is in brain-computer interfacing as well, specifically brain-computer interfacing with respect to music. And so I'm going to, this is what I was doing with Amatria. So if you are new to brain-computer interfacing, I just wanted to give a little demonstration of a working brain-computer interface system for my PhD. So this is me using my brain or my mind to control a spaceship that's trying to shoot these white balls. And you can see that those red lights are flashing, and every one of those flashes is being picked up in my brain, and whichever one I'm attending to is determining the rotation of the ship and or if it's shooting. And so this is actually a very common BCI protocol. BCI EEG requires a lot of neurons in your brain to be firing in synchrony so that you can create a large enough signal that can be measured and used to control things. Okay, so knocked it out. So in brain-computer interfacing, we start with the mind, the brain, and our ability to control our mind or to direct our intentionality towards something or another. And typically in this world, there's a variety of applications that we can imagine for brain-computer interfacing, many of which are involving some advanced technologies like virtual reality and augmented reality. My particular expertise is in transforming brainwaves into music. And then this particular project is about robotics. Robotics is something that I've been doing for a while. When I was at Georgia Tech, I worked in the robotic musicianship group. This is Shimon, a marimba playing robot who can improvise and listen. This is Shimmy, a portable robot that dances along with the music you choose to listen to. And this is a robotic drumming prosthesis for a drummer in an accident. And so when I joined this lab, we were working on this interesting robotic drumming third arm project. So drummers are notoriously involving all of their limbs at the same time. And this interesting, quirky project decided to try to explore what would happen if a drummer had a third arm. So we engineered this robotic system. And the interesting thing about robotics that are attached to your body is that they're actually not attached to your nervous system, unlike your normal limbs. And so the challenge of getting to control this arm is actually very challenging, especially when all of your arms are already occupied. So in this task, I actually used an EEG to help this drummer control their arm. Here's a demonstration. And this was funded by the NSF, a grant that I wrote. Here's a demonstration video of that working.
We believe that if you augment humans with technology, humans should be able to do, or would be able to do much more.
Okay, and so this past few months, I've been interested in this idea of making a brain-computer interface for Amatria. So starting off with those same brain signals, how can we go from there to create a sort of creative interaction involving music, kinetic sculpture, um, and have those really interesting interactions? This is a very exciting idea to me, and when I came to this project, I had no idea how to operate Amatria, so I'm very grateful for all the help Living Architecture Systems group. When I first got here, I joined Greg Lewis, who is the director of the Socio-Neurophysiology Lab, and got involved with this project classifying EEG brainwaves with some other really talented grad students, Beta, Akil, and Aiden. So classifying EEG brainwaves is a way of trying to figure out what a person might be thinking about. And so we used a data set of EEG involving people doing mental arithmetic or doing rest. And so the challenge is, given these quite complex nonlinear signals, how do we extract from that to determine what someone is doing? Whether they're active or inactive? And this involves deep learning. And I'm very excited to share these results. So we looked at two different things, the effect of different electrode positions and the effect of window size. And so these are some corollary results, but this shows a very high accuracy of classification for different electrode positions. This is all the electrodes, 23 electrodes, even down to just a single electrode. And then as well as a window size. So even with 0.25 seconds of EEG data, we have very high classification rate. And we've submitted this to be published in the IEEE International Conference on Systems Management and Cybernetics. That's very recent. And so I guess about November, I started talking to Kadi and Andy and became aware of this beautiful sculpture. And given my background in music technology, I was really curious what it would be like to control this with a BCI. And Andy and Kati introduced me to the Living Architecture Systems group. And for the last few months, I've been working a lot with Michael Lancaster, Rob Corbet, Matt Corbet, and Andreas introduced me to them all. And Peter kindly also has been active with this as well. And with this, I've been learning Amatria, and the way that I approach learning is often through teaching. So I had the help of a very talented undergrad student named Joshetta, and Joshetta and Michael and I would meet every week, and Michael would explain to us some of the inner workings of Amatria, and Joshetta would then get an assignment, some sort of creative assignment to help learn it. So let's look at a demo video that she made where she presents some of the software that is behind the scenes in Amatria.
Achieved to do this week was to be able to create a client, an OSC client that essentially is here, that basically sends a message to the server that then triggers a response in the Amatria. So essentially, to just break it down, this is the OSC client creation script. So we created a client and sent a message to BCI, the message being a float 1, 2, 3. And over here, in the server, what that does is basically it receives the message and then it prints into the console the fact that the BCI signal has been received using that string, the message that has been received, the actual message, and it switches then to the behavior scene that I created called the BCI1. So just a quick demonstration of all this happening. Okay. No. I need to quit first. Node server.
This is the code that's running Amatria.
Opens up this, and once I log into the control page, you can see that I'm actually currently in the default behavior scene as of now. So that's reflected here in simulation. And once I run the script, what should happen is the simulation should be triggered to reflect the switch in the scene to BCI1. So once I run that script, there we go. So we have this new scene that I created, which essentially just involves all these double rebel stars that charge and then discharge, sending, kind of like these lights upwards. That's pretty cool. But yeah, and you should also see the fact that the BCI signal had been received by the server and the actual message that was received by a server printed in console. So yeah, that's about it.
And interacting with this sculpture learning, this has actually allowed us to make learning resources available for students at IU. So hopefully in the future, undergraduates or any student at IU can get involved with creative projects like mine. This is a brain-computer interface project, but we could imagine data from all sorts of sources being used to influence Amatria's behavior. And so Joshetta got very, very busy in the middle of the semester. And so I reached out to some people at the Jacobs School of Music, in particular Ben Riki, Kunda Yu, and Dr. Scott Gibson. These are Dr. John Gibson. These are all composers. The use of BCI in music goes back almost to the origins of EEG. This is a picture of Alvin Lucier performing his famous Music for Solo Performer. Sits on a stage with an EEG headband, and those EEG signals are connected to amplifiers, which are beating drums all around the performer. And so, fortunately, I just said, we have this BCI project with Amatria. John, do you have any students that might be interested in it? I got the interest of several people, and Ben and Kunda have been really active these past few months working on that. So here is Ben showing us how to do this with Maxim SP, which is a visual coding language.
These waves are R1 and SS2. I have subscribed to various things in the sim. And this slider here will scale a message from 0 to 1.5. And that should go to the server and then modify stuff in the sculpture. So we'll see.
So you can see it activating there. One thing I particularly like about this is
this is modifying both the intensity and the velocity of the waves, and hopefully we'll be able to replace this scale, this slider, with some BCI in the future.
So Ben is operating this sculpture from his laptop, sitting outside of Amatria, and he is doing this via a local Wi-Fi connection, and he's screen sharing. So he doesn't have to download any software per se. He can walk up to the sculpture, connect to its Wi-Fi, and start to program. I think that's very exciting, and will make programming with Amatria much more accessible in the future. He's a composer,
These waves are R1 and SS2. I have
music composition. Here is him first. There's interactions there. And so I like this potential for future work. And so to make BCI even more accessible, we've used this platform called the Muse, which is a wireless EEG headband with 4 sensors. It also includes some heart sensing and an accelerometer and gyroscope. And so with this particular platform, which I've used in the past, a member of the public within a few minutes can be using a brain-computer interface, which is quite a improvement from existing systems, which are actually technically quite complex and require a lot of setup and even cleanup time after that. So this particular platform, I think, has a lot of potential for use with the public. And there's this Mind Monitor app that allows us to acquire the brain signals. And I've recruited a high school student named Ethan Cantrell, who has been active collecting data with the Muse system, which we'll use to create a classification engine. And Larry Zhang has been his mentor. He's a current PhD student. And so they've both been involved with the project. So let's look at some BCI interactions here. So here is Ben and Kunda just last night. This is a breakthrough moment for us. This is the first time it was actually really working. You can see Ben with the Muse headset on and Kunda, and they've been working together to make this happen. And so let's look at some of this. Okay, the volume's a little low. These are music. Amatria has a 10-channel speaker system, and that is very, very interesting to Kunda and Ben. And we're working on ways of making it possible to send 10 channels of audio at the same time to create a really nice immersive audio experience as well. Here's a BCI from Ben. It's the Mind Monitor app. It's acquiring his brain signals in real time here. There's the moths that when they vibrate make this nice sound, and it's really interesting to hear those along with the music that's created. This is my partner Claire Miller. She's a MFA in ceramics here, and this is her using this filter. This has a beating sound in the background. That's Amatria, and you can kind of see from this, you know, how surprising it can be to have such a large sculpture responding to brainwaves. And so she's sitting right now. But this is the sort of interaction that I can imagine for future people members of the general public interacting with this sculpture. Okay, so planning for the future. I've been involved with writing a grant for the IU Public Arts and Humanities Project, which partners IU with civic organizations. And this grant is designed to bring members of the general public and those of Southern Indiana into closer relationship with IU through the arts and humanities. And I've been involved with a collaboration with Wonder Lab. We're trying to create an accessible STEM platform. And Wonder Lab is a local museum of science and of health and technology, specifically targeting learners of all ages. And I've been working with their executive director, their museum experience director, and Greg Lewis and Deirdre to make this this particular BCI platform with Amatria something that has a very large impact for the public, that will allow people to come in and have that sort of BCI experience. And so this is something that I think is really, we can leverage Wonder Lab's expertise in terms of their reach to bring people in. This is some, I think, potential future responses. These are children using the Muse system and having this very early experience of brain-computer interfacing. And here is what I imagine, how I imagine we might be able to take the experience of Amatria and bring it into classrooms. This is just a very small portable part of Amatria, but you can imagine being controlled by brain signals. And if this grant is successful, which we hope it will be, this will be something that appears at IU, available through First Thursdays, which is a monthly art exposition, as well as the First Friday gallery walk in Bloomington. And also we'll be using Wonder Lab's expertise in creating teacher workshops to create a curriculum around this BCI STEAM platform and administer it to teachers of middle school students in Southern Indiana so they could take this platform into their classrooms and use it to teach. And all that is very exciting to me. And that's what I've been up to. Thanks again for everyone who's been involved. It's been wonderful to be so welcomed into the community, and I'm looking forward to future work with Amatria.
Thank you so much, Mike. It was so cool seeing, the results of what you did, and especially seeing somebody, for the first time actually playing with Amatria in a way that was intended from the beginning, where the idea was always to allow, people that are not necessarily part of Philip's team to actually interact with the sculpture in a programmatic way, and kind of living out their own creativity with the sculpture as an outlet. It is really cool to see how far you got, and it is really, really fascinating. And I hope I sent you an email about this. I really hope that in the fall when hopefully tours can be available again, like monthly tours can be available again, that we could incorporate your BCI in some form into these tours, because I think that would make those tours even more interesting. I can only imagine how much fun elementary school classes, middle school classes, or even IU personnel would have just being under Amatria and using this BCI. So this is really promising. Thank you so much, Mike.
A pleasure.